Hi everyone, I'm Andy. I'm a data scientist here with the Urban Big Data Centre at the University of Glasgow. And today I'm going to be showing you how to build a time series chart using React, D3, Material UI, and we're going to use some data from the CCTV object detection project at the Urban Big Data Centre here. So we've got this web page and an API behind it where we can request some data. The data is kind of object counts that were taken from CCTV snapshots at different areas throughout Glasgow, and it works really nicely with our time series chart here. So this is what we've got. We've got a chart built with D3, so we've got our scales and axis we're going to be building, and we've got our line chart here which represents the CCTV object detection data, and we're going to use Axios framework, the JavaScript framework, for kind of requesting data directly from this API as well. And you'll notice up here we've also got a date filter, so something that's really important kind of with time series charts is to make things as dynamic and as responsive as possible in kind of modern web development. So if I'm clicking it through and I want to see different narratives in the data, I could even go up to the last 7 days. It's going to show me and immediately kind of re-render the chart in D3 to show that. So one of the reasons I decided to do this guide was because it's a little bit tricky to integrate React and D3 with one another. So these two frameworks are really powerful modern web frameworks in JavaScript that let us kind of build highly performant data visualization web pages, but they both want to edit the document object model, or the DOM, which gives us a bit of problem in terms of what renders on the screen. So there's a few workarounds for this, and I'm going to cover that in the video today. So one of the things that we need to make sure that we have, one of the prerequisites for kind of completing this guide is having Node installed in your machine. So React is started on our local host at port 3000, and that's going to run on a Node server. So we need to make sure that we've got Node installed on our machine before we start. And if you don't know how to do that, you don't have Node installed on your machine, then there's a wee link in the guide below. I think it's also worth mentioning that this guide, although we're going to start from the basics, and I will cover some of the basic concepts of both React and D3, it's going to be really useful if you have some at least some understanding of how JavaScript works and how React is a single page application that's kind of dynamically rendering stuff to the browser. So some understanding of both React and JavaScript would be really useful. We're also going to run a few commands using the terminal as well, or the shell prompt, just to kind of get the server start up and running to manage our node modules. So we need to be a little bit comfortable with running commands on the terminal here. So after we've built our time series chart using React and D3, it's also going to be really important to make it responsive for different screen sizes as well. Something that I really don't like about a lot of modern data visualization web pages is that they look really terrible, or they load really slowly when you open them on a mobile. So after we've built our time series chart like this, we're going to make it responsive so that it will load in a nice fashion on different screen sizes as well. And don't forget that we've also got the GitHub repository, which has all the code for this project, and you can follow along and see a live demo of the time series chart as well if you just want to skip in and look at particular code snippets as we go. Okay, so I'm going to begin. The first thing we need to do is make a folder on our computers to host the project. So I'm going to open up my Finder window here, and I've got that folder time series chart ready to go. So I want to make sure that in my terminal window now, I'm going to navigate to that folder. Right now, I'm just at the root folder, so I just want to do a change directory command. And on Macs, I can actually copy and paste the exact path, and I can navigate right there. So I'm just going to do a quick check, make sure that folder's empty right now. And we're going to use this folder to create our time series chart. So I'm going to use a command called npx create react app. And this is going to build me a template folder structure with a lot of the kind of key files that we need to run our React app. It's a really useful command, and I would suggest that anybody kind of, rather than rebuilding your React app from scratch, this is a really great way to start off with a blank space. So npx create react app, and I'm just going to provide the name of time series chart here. I'm going to run that folder, that command, and we're going to see that our new React app is being created inside our folder. You can already see it's appeared here. And we're just going to wait for that to install. Okay, brilliant. This is looking good. And we've got a Git repository there as well in case we want to publish to Git. And that's that run. So we're going to see the commands up here. The only one that we're really going to use today is npm start, which is going to start our development server. And we're just going to be working locally for this project today. But we also need to make sure that we're changing the directory to the time series chart, because right now we're in that parent directory here of time series chart, and we want to be in this child directory here. So we're going to go cd time series chart and npm start. Brilliant. And that's going to hopefully load up my development server here in the local host with, yeah, that's the template React app. So we're going to be able to modify all of this code so that it looked like it did just a moment ago. And let's get started. So I'm going to open up my code editor now. I use WebStorm, so we're just going to bring up WebStorm, and it's a good idea to kind of use VS Code or Sublime or one of the kind of more friendly code editors for this project. It's quite a lot of files that we'll end up with typically in a React app, and just going to bring that over here so you guys can see what I'm doing. Go to Open, Documents. It's my time series chart, and I'm going to open that child time series chart folder here. I'm going to trust the project, and that's just going to bring it up here. I'll move it over to my second desktop so that we can just easily switch between. And let's take a look at what we've got already in the folder structure. So this public folder is mostly full of static files that React will render at build time. So we keep our images and our fav icons and stuff like that in here. It's also got the index.html file, which we're not going to edit today, but just know that with React apps that we're going to render the entire React app inside this div with the ID root here. So what we're really going to be interested in is the source folder, the src folder, and we've got our general app CSS file, which contains some kind of core basic CSS commands to style the app. We've got the app.js file, which is our kind of index file. This is the kind of top level file that will render all of the child components below it. We've got another index CSS file here, which is styling our body, and that's about all that we need to really pay attention to for now. So anything that kind of any components that we create will be also created inside this source file. And it was just worth mentioning, this package.json file contains the modules, the node modules that we'll use to kind of build this project. So as we go and install modules that we'll need, such as Axios for kind of making the API calls, we'll need D3 for building the chart, we'll need Material UI. We're going to install them and it will appear in this package.json as we go along. Okay, brilliant. And I'm just going to bring up my app.js file here, and we're going to start it off now. So the first thing that we want to really do is use Material UI to set up our styles. If you haven't seen Material UI before, I'll just show you quickly now. Material UI, and we'll just go to the home page. In fact, yeah, this is kind of what we're going to use. So we've got all of these kind of ready-made components that we can use within React apps. Things like buttons, sliders, icons. It's a really, really useful way to kind of start building applications in React with some kind of pre-made components that work really nicely, and they look good. And the key thing is that we can kind of customize them from that point. So if you remember what our date filter component looked like, we're going to build that using a button group, which is got some really nice built-in functionality as well. But to do so, we need to start just to install Material UI on our system. So I'm going to stop the server. First thing I need to do is bring up the terminal, and I'm going to stop the server here. I actually have a server window, a terminal inside WebStorm, which I'm going to use for this. So I can just run the npm start, and that's going to be starting the development server again here. because I find it a bit easier just to kind of have the code editing and the terminal window in the same project. This is a really nice feature. So we want to install Material UI, Emotion React, and Emotion Styled, and these are the kind of libraries that we'll need in order to be able to work with Material UI. So npm install @mui/material, and then I can just tag these along. Emotion React @emotion styled, and I'm going to make sure that's all installing there. Okay, brilliant, and that's going to have installed all of those modules. So I can just go over to the package.json file and just make sure that we've got them listed in our dependencies, which we do. We can see here we've got the Material UI emotion packages in the dependencies of the project. Okay, great. Just while we're working on the config of the styles related to this project, I'm going to go over to Google Fonts and I'm going to install myself the JetBrains Mono font, which we're going to use throughout the application today. So Google Fonts isn't necessarily the only way to install fonts into a web app, but it is certainly an easy way to do so. So we're going to use it today. And I want to make sure that I've got the extra light font selected here and the regular one as well. And I'm also going to use semi-bold, which is here. Brilliant. So what I'm going to need is this code snippet here, which I'm going to go take it to my app and then paste it into the HTML file, and that's going to give us access to JetBrains Mono kind of throughout the application, both in Material UI. We'll need to set some CSS rules to get it to access throughout the application more generally as well. So yeah, I'll walk you through this as we go. I'm going to copy that, go back to my project, and I'm going to go to the public folder, and I'm going to open the indexed HTML and just paste this at the top of my head. So that's giving us a direct connection to the Google Font API, which is going to load our JetBrains Mono font. So we're not going to get that inside our application yet. If we go back over to the browser and check out the React app, we can see that nothing's changed. So what I need to do is open up my index CSS, in fact my app CSS file, and I'm just going to add a comment at the top of this that says body, everything, and then I want to make sure that this is a global font, so I'm going to set font family equal to JetBrains Mono, and I'm going to use monospace as my fallback font as well. And now let's check the app inside the browser and see if that's worked. Let's refresh. In fact, we haven't started the server, so npm start, and let's just reload this. Yeah, and we can see the font has changed throughout the application as well. Okay, that's brilliant. But when we start to use Material UI, these styles are going to be overridden. So in order to tell all our Material UI based components to use the font family, we need to create a very simple kind of Material UI theme that is going to govern the styles that are inside our customized components. So first thing I want to do to create a Material UI theme is go back to my project, and I'm going to go to the app.js file. We're just going to create a theme inside here, and I'm going to import some stuff from the Material UI styles folder. So I'm going to import the theme provider, and I'm going to import create theme from Material UI, and I think that would have worked. Let's just check. I think we needed the styles on there in the end. So I've imported the theme provider and the create theme function from Material UI, and now I need to create my my theme. So I can call that const theme equals create theme, and then we can open this up, and I'm going to have my typography option set here, and we can have, in fact, just all variants, another object declaration. And what we're just doing here is setting a default font family for every typography element, which is just going to be all of our text within the components that we use, and we can set this as JetBrains mono, and just make sure I'm commenting everything quite nicely here. And we go back to the outside, and whilst I'm here, I'm also just going to set a palette, which will be our color theme for the project as well. And our primary color theme has an object called main, and that main, we're going to use hex codes to, in fact, that's not an object, that's just a hex code in a string. We're going to use hex codes to kind of, we're going to use hex codes to provide the color values throughout the project. So 2196F3 is a nice blue that we'll use, and the other one, the secondary one, which is quite useful in Material UI because we get color contrast between the primary and the secondary colors. Looks quite nice if you ask me. The secondary one is going to be, so I'm just reading this, 1565C0. And that's just a slightly darker blue to provide a different contrast again here. And that's it. That's going to be our theme that we'll use for the project. Now we don't need to worry about that. We're going to use them later on. Okay, great. So now that I've got this, I want to make sure that we're connecting this theme to all of the Material UI components that we'll use inside the project. So bearing in mind that this app component is our top level component, if we provide a wrapper, which is this theme provider, like this, we can wrap it around just using a theme provider, theme equals theme, close this brackets, copy that, and we're just going to make sure that the theme provider is here. That means that everything inside our application, because everything will always fall within inside that theme provider, is going to be have access to the Material UI theme. Brilliant. So if we go over to the browser, we'll notice that nothing's really changed at the moment because we're not using any Material UI components. Great. So now we want to have a place to build our components. We're not going to build everything inside this app file, so we want to make sure that we have a place inside the SRC to add child components. So what we've done already is to build the Material UI theme and to add Google Fonts to our project. So we've kind of got a lot of the style configuration set up, but we're going to need to build some components now. So I'm going to go into my folder structure here. I'm going to create a new directory, a new folder inside the SRC, and I'm going to call this components. And I'm going to create two files inside components, one called chart.js. I'm going to add it to GitHub, and the other one is going to be called datefilter.js. Both JavaScript files, both will render the two React components that we're going to see inside the final app. So obviously chart is going to render the time series chart, and the date filter is going to render the date filter. And we're just going to work our way through building these components today. We're going to start with the date filter, and then we're going to move on to connecting the date filter and the chart, and then we're going to flesh out our chart as much as possible as well. So just reflecting on the folder structure a little bit here, we've still got our public folder. We're not going to use that much anymore. So now that we've got our kind of Google Fonts loaded into the indexed HTML, I can probably close this file down, close down the CSS, close down the package.json, and we're mostly going to be working within the date folder, the chart, the app. We don't need the README either. So we've got all of that stuff kind of inside the SRC parent folder here. And now we've just created a new directory called components, and we've got these two files, chart and date filter, inside them here. So first thing we're going to do is open up the date filter, and we're going to build our date filter button group. Now working inside the date filter JS file, which is inside our components directory here. Just going to add a comment at the top, says component to render date filter using MUI toggle button group. And we're just going to add some very simple boilerplate React code, which is going to give us one of the most simple functional React components there is. So I'm going to call this const date filter equals arrow function, and then we're just going to return an empty string really that just says hello world, just inside these empty brackets here. And I'm going to save that, and we're going to make sure that we are exporting this component so that we can access it throughout the project. So I'm going to export default date filter. Brilliant. So that's not going to render anything on our browser window yet because we've not imported it into the app.js file, which is going to render everything. So everything that we're currently rendering is inside this file. So what I want to do here is just get rid of everything inside this div with the class name app, and I just want to go to the top of the file. I'm going to import my date filter from components date filter, and we're just going to add the date filter in here, close the brackets, save the file, and we should be able to see our hello world string right at the top of the page. So that's brilliant. We've now got rid of the template React app, and we're starting to write our own components. Okay, great. So now we want to try and actually build a toggle button group that's going to store our date filter. So we're going to need a few MUI, material UI components in order to do so. Let's go back to date filter and let's import the toggle button component. Import toggle button from material UI, and we also want to import the toggle button group. And whilst we're here, we're also going to import the styled component, which is just going to help us to be able to customize the toggle button and the toggle button group, and we'll see how that works later. So now that we've got our toggle button and our toggle button groups, we can start to put them inside the return statement of the date filter component. So naturally, we're going to want to wrap our toggle buttons in a toggle button group, and we're just going to close that here. Toggle button group, and then we're going to want to put inside 5 different toggle buttons, which are going to correspond to 7 days, 30 days, 90 days, 150 days, 365 days, and clicking on each of these is just going to cause that chart to re-render with the right data. So first thing is my toggle button, and I'm just going to close. In fact, I need this to have a value, and that value is going to have 7 days, and I'm also going to give the same associated value just so that we have an associated value here as well. So I should probably explain that this between this closed brackets is the text that we're going to see displayed in the button, and this is the value that's actually associated with that button click. So we'll use this value eventually as an actual date variable that will be able to tell our chart which date to start from, to start the data representation in the chart from. So I'm just going to copy this and I'll paste it 5 times, so 4 times, so we have 5. I'm going to change this to 30 days, and I'm going to change this to 30 days as well. The next one is 90 days, so we're going to have 90 days here, and we're also going to have 90 days here, and then we're going to have 150 days, and 150 days here, and then we're also going to have 365 days, so we're going to get a full year representation right at the bottom down here. So that's all of our toggle buttons set up as well. We want to give our toggle button group a color, and we're just going to use the primary, which, if we remember in our theme in the app.js file, we defined our primary color here. So because this is already listed as main, that's just going to use the blue that we've designated associated with the primary main color, and we're going to give it a default value. So that means which is the selected button by default, and by saying 7 days, that's going to mean that 7 days, this button is our default selected value for now. And if we give it an exclusive prop as well, that means that we can, with exclusive set there to true, we're only going to be able to click one button at a time here. If I didn't have the exclusive prop, we might be able to select 7 days and 90 days, which doesn't really make sense in this context. So if we save the file now, we should be able to check it out in the browser after it's compiled, and we can see our date filter button here. Now it's not working the interactions yet, but as you can see, we've got a pretty nice looking date filter without really putting in much effort at all, and this is all thanks to Material UI. So what we need to do now is to add functionality to change the dates in the date filter button group. So what we're going to need to do in order to build the functionality here is a component state. So that will store the value of the toggle button group. So if it's 7 days or 30 days, we need a state variable that's going to store that value. And we need a change handler. So the change handler is going to way to update that date selection that's stored in our component state when a new button's clicked. So really we've got the component state and the change handler, and we can use React hooks to make this nice and easy, nice and painless. So we'll be using the useState hook, and we're going to be able to set our state and store our state with that useState hook. So because we're going to need access to the date selection not only in the toggle button group, which is going to be able to update the date and will represent the button that's currently selected, but we'll also need it in the chart component, which we haven't built yet, which will need access to what the date selection is in order to reprogram the axis correctly. If we build the component state inside this date filter component, our chart file is not going to have access to it. So what we need to be able to do is to start working with this component state inside the app component, which is our parent component, and it will be of the chart component too. And then we can store the component state inside this app and pass it down to both the date filter and to the chart file. So we're going to do that now. We're going to start working inside the app.js file, and we're going to be inside the app component. And I think it's probably a good idea to start working with actual dates now. So I'm going to just declare a starting dates object inside my app component. This starting date object is going to hold the keys which will have the actual date values that we can use to update the chart as well. So I'm going to have 7 days. I'm just going to leave this blank for now with a comma, and I'm going to have 30 days with a comma, and I'm going to have 90 days with a comma. I'm going to have 150 days, and lastly we've got our 365 days here as well. Okay, brilliant. So now I'm going to have to program the variables that now I'm going to have to build the variables that will store our actual dates. So I'm just going to bring up and copy in one of the pre-programmed variables. Dates are a wee bit tricky to work with, so I do suggest that we just stick with these ones here. And I've got one loaded up here. So as you can see, what we're doing here is we're creating a new date, and we're setting that date to -7. So that's going to give us 7 days ago. And in order to get the correct format of the date variable, we are setting the date with 0 hours, 0 minutes, 0 seconds, just so that's midnight, really, 7 days ago. We're creating that as a new date object, and then we're going to make that into a string, just so it's not going to be mutable throughout the application, and it's going to be easy to work with. So all I need to do here in order to get my other date variables is to minus the same corresponding number of days. So I can copy and paste this into all of the other object keys, and I can make sure they correspond with the correct key value, which is 30, 90, 150, and 365. So this is giving me a string representation of all of the dates that I need to plug in both to my date filter and to my chart component. Brilliant. So now with my date filter set up here, I want to pass this starting dates object in as a prop to my date filter component. So that's going to give my date filter access to the starting dates object as defined here. So now I can go back to my date filter and make sure that I'm getting the starting dates as a prop, and then I can start to use this within my component here. So in fact, what I'm going to do is exactly that. I'm going to change the value. I'm not going to change what's appearing as the text in these toggle buttons, but I am going to change the value here. So starting dates will be 7 days. I'm just going to make sure I've got that formatting right. I have. In fact, I think I'm just going to remove any spaces here just for easiness. So that would be 7 days. And I'm going to copy and paste this into all of my other values for the toggle button group. Just like this. And we're going to make sure that they all correspond to the right starting date, which is 90, 150, 365. Brilliant. So that's not going to have affected our app in any way. In fact, what we haven't done here is set the value starting date 7 days, which is very important because that will now correspond to the same value as this toggle button. And yeah, we're not got any other interaction here because we haven't defined our change handler or component state yet. So but it's kind of nice that we've now got a toggle button group that are associated with the right date values. So I want to go back to the app component and I want to import the useState hook from React. So I can import useState. And that's going to be the way that we both store and change the application state. So I think we need to add our application state handler now. So I'm going to say const date selection and set date selection equals use state. And because we've defined our starting dates above this declaration, we can access the starting dates and give it a default starting default state of 365 days. So that means that we've now got our component state, which is represented by this date selection variable, and we've got our change handler set date selection, which causes this date selection variable to update. And we're using a default initial state of starting dates, 365 days. Brilliant. Okay, so this is all defined within the app component, but it's not being passed down to our date filter component. So what we need to do, in the same way that we added a prop to pass the starting dates object down into the date filter component, we need to pass the date selection and the set date selection change handler as well. So I'm just going to add these as props like this. Date selection equals date selection and set date selection equals set date selection. So now we have these passed down as props into the date filter component. We can add those in and start working with them actually in the date filter. So I'm going to go back to here and I'm just going to add them and make sure they're passing through and set date selection, and now we've got them added in. So what we want to do now is actually hook up the toggle button group so that the value represents this date selection state, which is declared in our component, in our app component, and the change handler, which we haven't written yet, will trigger a new date selection. So it will update that date selection when a button is clicked. So the way that we do that in our toggle button group is by adding an onChange event, and then we can use an arrow function actually within inside the component props. So I can just say on change, take the mouse event and set the date selection with e.target.value. Okay, so that's a little bit complicated for some of us who haven't written much React code before, so I'm just going to go over what this actually does here. So this onChange handler is going to trigger every single time a user clicks a button inside here. And what we're doing is we're taking that mouse event, we're gaining access to the event itself in the parameters of the function here, and we're passing that event down to the date selection change handler, and we're passing the new value of the date selection to be e.target.value. So that's the event, and it's the target button that was clicked, and it's the value of that target button. And as you notice here, we've got all of these values declared. So this is automatically going to update our date selection with the value of the button that was clicked. So if I just save this, and we can check that that's worked. So I've got, and now inside the application, I've got an interactive date filter. So we can see that that's updating nicely. The thing is that at the moment our date filter sits at the top of the page, so this isn't very convenient for our users. They're not going to be able to see that very easily and work with it. So what we want to do is provide a bit of layout here with the Material UI box component, and that's just going to style this a wee bit nicer in terms of the layout on our page. So I think it makes sense for our layouts to all go inside the app.js files so that we can just kind of keep them consistent. So what I'm going to do is import a box component, which is going to act as a layout wrapper for my date filter, and then later my my chart component as well. So I can import the box. I think that's the correct box. So import the box from MUI material, and I'm just going to wrap this date filter in a box here, just like this, and I'm just going to make sure this is nice syntaxed, nicely spaced out, and I've got my box there. So that's wrapping in a box, but it's not adding any styles to the layout of the page. So if I save that, it's just sitting around the outside of it, not doing anything. So I want to change some styles for this box, and we're going to use this box to control the layout of the date filter. So first thing I want to do is just to show you this SXproc, which is a really useful way of injecting customized styles into MUI components, and it basically just uses a CSS-like syntax, which gives us access to most of the CSS kind of rules that we would need to style different components in different ways. And it's a really useful way if we've got one-off styles that we just need to add on ad hoc basis to different components throughout the project. We can use this SXproc prop just to do that. So the three things that I want to do here, there's a few things that I want to do here. I want to set the box to display the flex box. I want to align it so that everything comes to the center and justify it in the same way as well. And then I want to get it to occupy 33% of the viewport height, which is just going to space it nicely in the middle of this area here. So it's going to come up here and it's going to align everything center. So we should see our date filter kind of appearing somewhere around here, nice and centered. So I can do that now. I'm just going to use display equals flex. You don't need to use backticks. I quite like using backticks here because then we can insert different variables in at later points, but you don't need to use backticks. Align items, I'm going to use the center as well. I'm going to justify the content to the center, and I'm going to occupy 33 viewport height, which means that if we check it out in the browser now, we can see that our depth filter is nicely spaced out. That's brilliant. Okay, so we've got our date filter working nicely. We'll probably want to move on to developing our chart component now. So the time series chart, as we've already seen, it uses D3. and it's going to use D3, and there's going to be a slight integration with React. So for anybody that doesn't know already, I've mentioned it before, but there's a little bit tricky to integrate both D3 and React because they both want to edit that document, that HTML document, which is rendering in your browser, and we don't really want D3 to be able to edit that without React's permission. So we're going to use a little hook which is going to just nicely organize the responsibilities there, so they're not competing for control over the document object model. So the chart component is going to be developed in a number of stages. So the first thing that we're going to do is to create a responsive layout for the chart. We want this to be able to react really nicely to different screen sizes, so that on mobile devices our chart isn't displayed in a huge big format here, it just renders nicely in a small pocket. So we need to make sure that the chart is naturally responsive even from the very, very start. We need to start thinking about that before we even write any of the code to build the chart. Then we're going to make our API data requests to the CCTV platform from the UBDC. And the data that we're going to get back is going to be object counts at different times from a whole different number of CCTV cameras throughout Glasgow. It's a really, really nice data set, and you can go and check it out for yourself here, but we just use Axios to request the data directly from the API, and that will be fed directly into our chart component. So yeah, we're going to load that data into the chart component, test that it's all working nicely, and then we can move on to actually building some of the elements of the chart itself. So we're going to build the axis and the grid lines for the chart. Then we're going to plot the lines on the chart, and finally we're going to add some styles to the chart, which is where we'll really see it all come together and start to look really, really neat. So I'm going to start by adding a responsive layout in my app.js file. Remember, we've got our box, which is laying out the date filter to occupy 33% of the viewport height. We want something similar for the chart component, but we want this to occupy 67%, so the rest of the viewport height. I'm just going to close that box up there, and let's just have an empty string that says hello world, or something like that, and then we can see that this space is already nicely laid out for our chart to go inside of. Okay, brilliant. So let's move over to the chart file, and let's create a component here. So this is a component for rendering the time series chart using D3, and maybe we should put a note to say Axios for API request. And then I'm going to create a very simple boilerplate functional component, which is going to call chart equals arrow function, and then we can have a simple return statement here that says chart.js is rendering me now. So we'll see that updated in our browser in a second, and we're going to export default chart. So now we've just got that very, very simple chart component, which is rendering that string, and obviously it's not in the browser at the moment. We haven't plugged it into the app component, so we're going to go back to the app component here, get rid of that hello world string, and we're going to import the chart component just like that. And then inside our box, we can add the chart component like this, save the progress, and in the browser we'll see this string, chart.js is rendering me now, which is brilliant because that's our whole kind of component structure set up for this simple project. We've got our top level app component, which is controlling the layout and then rendering these children, the chart and the date filter component here. So now we can just work within chart.js and we can start to build up the logic that will go inside there. So inside our chart.js file, we need to change the output of the file. So at the moment we've got this string, but really what we want is a container here to start building our chart. Now D3 uses SVG quite commonly to render and kind of dynamically update elements within inside that SVG, and this is where we can come into a problem with updating the document object model. If that's SVG is rendered by React and then D3 tries to manipulate it in certain ways, then we're going to run into some really tricky situations. So this is a nice method of kind of working around that a little bit, but what we still need is an SVG element here. So we want to return an SVG, and that's all we're going to actually return from this chart file. The rest of the logic is going to be done by React and D3, and they're going to build and edit that SVG as we kind of load data into our chart. But what we do need to do is give the SVG some properties so that we can access it. Just going to load that down there, and we need to give it an ID property, in fact, an ID property, and that ID is going to be chart SVG. And we also need to set it with some basic styles. Those basic styles are going to be the height, which we're going to set to 100%. So we just want that to occupy 100% of the container. And what we're starting to do now, same with the width, is to make sure that because we're using percentages, not pixels, we're making sure that this SVG is always going to take the same size as the responsive component, and that's going to become more relevant because these dynamic sizes are going to be then passed down into the chart elements, which will get built, and it's going to cause our time series chart to be much more responsive than if we were setting really static dimensions here. So that's it. That's all we're going to return from the chart component. The rest of the logic is going to be handled by React and D3, and as we can see here, now we're rendering nothing in the middle. What we're actually going to get, I think we'll be able to inspect it and have a look. If we have a look here, yeah, we can see our chart SVG here, and that's going to be the container for the chart to be drawn in. So I want to start now by installing D3. I haven't got a D3 installed in my package JSON yet. It's not listed in my dependencies, so I want to stop this server in the terminal window so I have access to some npm commands, and I want to do npm install D3. Okay, brilliant. So now that I've got access to D3 in the project, I want to make sure that I restart the server because I can forget to do that sometimes. And I can close down this package JSON, and I can go over to my chart file where I'll need to import everything as D3 from D3. Brilliant. So now I've got access to the most powerful kind of modern framework for charts and data visualization right here in my chart component. So I've explained a little bit about the problems with integrating D3 and React, and it's all to do with that document object model integration. So what we want to do is tell React when to update D3 and to allow D3 to edit the document object model, and then when to take control of it by itself. And we want to do that in a use effect hook, which, if anybody is familiar with class-based components in React, is really similar to the kind of component did mount or component did update. The use effect hook is basically going to render each time that the component updates, which is really handy for us because we can draw our chart again if a new date selection is made. So for example, our chart might redraw now. And it's also going to render the first time that the chart loads as well. So this use effect hook we can import from React directly. And if you aren't familiar with the use effect hook, it's really useful just to kind of go through some of the documentation that React have on this. It's an absolutely fantastic component hook, which I've used in pretty much every kind of React component that I'm building these days. So go and have a look at that, and you'll start to learn really quickly on the React documentation, that is. So I've now got access to the use effect hook inside my chart, and I'm just going to write the structure of it here. So use effect. That's going to trigger every time my component updates or mounts for the first time. And what I've got here is an arrow function as the parameter of the use effect hook, and the second parameter is a dependency array. So the dependency array kind of sets things to stop or to start another triggering of this use effect hook. So if I listed something in my dependency array, for example, the date selection, which we might do at a later point in the project, then the use effect hook is going to look to see if the date selection has updated before it runs. So these are a kind of way of controlling when our use effect hook runs. So we're not constantly re-rendering the chart unintentionally as well. And everything kind of within this arrow function here, we can have access to when that chart re-renders. So that's just gonna activate. So we want this function to do two things every time the chart component kind of mounts or something in the dependency array changes. We want the use effect hook to delete all of the elements that are inside the SVG drawn dynamically that render our previous version of the chart, and then we want it to redraw the chart entirely again. So it might seem a little bit kind of counterintuitive to delete everything that's in the chart, even though we haven't got anything in the chart yet. But if we don't do this, the chart will end up drawing a new version of itself on top of the old version, and this is the kind of issues that we run into with React and D3. So what I'm going to do is just add a comment here that says select and clear the chart, and we can do that by selecting the SVG element equals d3.select. So this D3 has the ability to kind of select different HTML elements on the page, and we can use selectors like IDs or classes to be able to do this. So remember we called our SVG element chart SVG. So that is now giving D3 access to the SVG element that's inside our page. And then we can use a D3 function SVG select all. That's going to select all of the children inside the SVG component, especially if I use the wildcard selector, and we're going to use that function remove. So that is selecting the chart and clearing it. And then we need to call a function, just adding a comment here so that it's clearer, to draw the chart again. And this is the really important logic that helps to integrate React and D3. We can use a use effect hook that's going to update at the right times, and it's going to select and clear the chart and then draw the chart again. So this is kind of owning the responsibility of saying who's got the control over the document object model, who can edit the components on the page. Is it React or D3? And this is a really nice way of controlling it here. So we haven't done that function. We haven't written that function yet, so that's going to cause an error. But this draw chart function will essentially re-render the chart on the page, and we're going to declare that just inside this chart component here, so that everything's nice and well organized there. So actually, let's just go ahead and declare the draw chart function. Draw chart equals arrow function, and we don't need it to do anything just now. We'll come back to that later, but now we're going to have no errors appearing in the system. So that draw chart function is going to update all the right points. So now what we're going to do is connect the time series chart to the date filter, so that the time series chart also has access to the date selection, and it can use that to form its access in and the right scales for its access, in different ways throughout the project. So I can do that in the very same way that I gave the date filter access to the date selection. I go back to my app.js file, and I want to pass in a prop to the chart component, which is just going to be date selection equals date selection. And now my chart will have access to that date selection, which, remember, is the component state that we're declaring here. And that's also passed down to the date filter component. And I just need to make sure that I'm declaring that up here in the props of the chart component. So I could log that at any point, and we could see our date selection is going to be inside the chart file. Okay, so what we need to do next is start to collect the data that we're going to use to render inside the chart. We need to be requesting this from the CCTV API, which I've shown you here, and we're going to be using a URL to do so, and we're going to make a GET request to that URL using the Axios library, and that's going to give us back some data on the starting date of the data request, the finishing date, the type of objects that are coming have been counted, so cars, buses, trucks, motorcycles, people, bicycles, the camera locations that are included in this, and then finally what we're really interested in is a records array, and that records array is a list of objects that contain a timestamp, so that's got dates and times, and it's also got the values, so that's an aggregation of all of the different objects that were counted at all of the cameras at particular aggregation levels throughout the course of the data collection. But crucially, we're gonna have this timestamp and the values, and that's going to enable us to plot the data on the chart as well. So next thing I need to do is install Axios. So I've quit the server, and I just want to install Axios like this, npm install Axios. Axios is a really great library for making different kinds of requests from client-side JavaScript applications to APIs or any kind of other requests that we might need to do. So we now have Axios installed, and I'm just going to check my package.json just to show you guys that that's in there now. Yeah, we've got Axios in here now, so close that down. I can import Axios from this chart.js file. So I'm going to import Axios from Axios here, and we're going to be making our request inside the file. So we've got Axios, and we've got the ability to plot our chart using D3. We've got the ability to kind of update it correctly using the use effect hook. And now we need to start focusing on how we're going to get the data into the chart component. So first thing I need to do is declare my API URL, and I want to declare the API URL somewhere here. I'm just going to put a wee comment in for myself. Declare API URL. This is important because we don't want to get this wrong, otherwise our data collection isn't going to work. And API URL, I'm just going to write it out for you guys so that it's easier to follow. HTTPS // Glasgow /CCTV UBDC.ac.uk. So that's going to take you to this page here, and behind we've got this open API which is going to let you request data from that object detection project. So /API, and then the endpoint, the specific endpoint that we're going to be using that's going to return the data that we need is the historic records endpoint. Okay, so that's our API URL declared there. And we want to turn our attention now to the parameters that we're also going to pass into the API as well. So we can pass some parameters like date before, date after, and the aggregation method. So if we want our aggregation to be daily or different. So it would make sense to have the data always running up to today's date, but then the starting date of the data, as we've seen in our kind of component state, the date selection might be 150 days ago, might be 90 days ago, might be 365 days ago. So we can set these as API parameters that's going to make sure that we're requesting efficient payloads from the API, and we're not storing too much data unnecessarily inside our client application. This doesn't matter too much for this kind of project. It's not going to be huge volumes of data anyway, but it's generally good practice for kind of front-end web development, especially when we're dealing with large volumes of data. We're rendering in a chart where we want to keep as little data actually in the browser as possible in order to make the application as performant for our end users as we can. So what we're going to do is declare some API parameters directly underneath. So I'm just going to add my comment here. This chart.js file is going to get kind of big, so I'm going to make sure that I'm adding as many comments just so I can find myself later on. And const API params equals an object, and we're going to pass this object directly into our Axios GET request so that we get back the suitable amount of data. So I'm going to use aggregation, and that's going to have a value of day. So we're always just going to request daily values. So it doesn't matter if it's going to be 365 days. We want daily values, or 7 days. We also want daily values. Of course, if we were being more efficient, we wanted 5 years worth of data. It wouldn't make sense to keep that aggregation method as day, but it's just to show you guys that we can change that aggregation method if we want to. The date after parameter we're also going to use, and we're going to have the date before parameter as well. So this date before is always going to be set to a new date, but what we want to do, and that a new date object I should say, will always evaluate to today's date. So we're always going to make sure that our time series chart is dynamic enough to respond to today's date, and obviously with our date selection declared in this way, we're always going to be dynamic enough to get 7 days ago. So that's not going to be a fixed date. You know, as we kind of move on to tomorrow and the next day, that's going to update again. So this date before, we're going to have new date, and for the date after, we're going to use the date selection. It's going to go up to today, but it's going to start from whatever the user has selected as their date selection. I can't leave that just there just yet, because we need to be able to format these dates correctly for the API. So I need to make sure that we're using the correct format of date variable, and I'm going to use the d3.time format function in order to do so. And I can just, it's close brackets there, and the second brackets gets wrapped around the object, and the d3.time format here again, and then just another pair of brackets around the new date definition there. And I'm just going to pass in the format that I want, which is going to be date, month, year, and we can control that like this. So %d, then a dash, and then %n, and then a dash, and then %Y. So date formats have lots of different kinds of, there are a lot of different kind of date formats, and these are all kind of tricky to work with. There's a lot of different kind of date formats that we can access through this particular kind of query string here, and I've got the percentages set up to represent day/month/year. These are kind of tricky to work with, so I do suggest kind of checking out some documentation on the different kinds of date formats that we can have. But this particular format works really well for our API. In fact, it's necessary for our API request, so I'm just going to leave that there. And that's our parameters set up nicely. So now we're ready to make the request with Axios, and we want to first ask Axios to retrieve the data, passing in these API parameters from the URL, and then that's going to return a promise. So Axios will make a request, and then whilst that request is processed and the data is sent back, this promise will evaluate. So what we need to do is have an axios.get function, and then we deal with the response from that request in a .then function, and we can kind of do what we'd like with the returning data inside that .then function. But this is because the data doesn't evaluate immediately. The request needs to be made from the API, and then the response needs to come back as well. So just to kind of help you guys understand a little bit of the syntax that I'm going to be writing just now. So for now, we're going to add this code directly underneath the API params declaration. Make Axios get request. Oh, excuse me. Make Axios get request. And we will move this at another point so that it is updating and making new requests at the right time. But for now, we can just check it out, axios.get. The first parameter is going to be my API URL, which we're going to be requesting data from. And then I've got some configuration options here, and I can set my parameters as my API params. So that's going to, when that executes, it's going to send off a request to the API URL and set the parameters just like that. So then I want to go to the next line and add a then function. So when that promise is resolved and comes back, what do we want to do with the response data? So inside the then chain function, I can add a function to execute, and that's going to be my Axios response is passed in here. And then what do I want to do with my Axios response will fall within this these curly brackets here. So at the moment, all I'm going to do is console.log the response just to make sure that we've got it and everything's coming through nicely. But what we'll actually do here is make sure that data is then passed into the chart component in an appropriate manner. So I think it would make sense to restart the server and head back over to the browser. And I just want to have a look in the console to make sure that this is all loading properly. And I can see, brilliant. I'm not going to worry too much about these errors just now because I know that I'm getting my data here. So this is my Axios. You can see it's been logged in the chart.js file, and I can see that my data is coming back. So this is what I'm interested in. And as I said before, we've got the aggregation as day coming back, the different camera locations that are included in my payload, the date after, the date before, and the object types and the records that are coming back here. So in my records array, I've got plenty of data here, and we can see that we've got objects which have a timestamp and a value. And this is what we're going to be plotting on the time series chart. And yeah, I think just noticing here, so that 365 days is come back with the right amount of data. Maybe you can't see that so well, but it says 2021 to 2022. So that's a full year's worth of data, and we've got all of the counts, and it was pretty fast as well. So I'm happy with that. I'm going to close that, and we've got access to the data inside of our file. So this is, now we need a way of saving this data somewhere so that elements in our chart can kind of access it. So this calls for another way to save component state. And how did we do that before? We used the useState hook. So same way that we did our date selection here, we're not going to need to use this we're not going to need to write this in the app component. We can do it straight into the chart component. That's the only component that's going to have access to the data. But we will need to use a useState hook in order to save the data. So we should do this at the very top of the chart component, and I'm going to say const data set data, which is going to be the way that we are able to set the data that's incoming, and use state. And it's going to be a default state of an empty object. And I'm noticing that we haven't imported the useState hook into the chart component yet. So I import useState from React. Great. So now we have the ability to kind of set the data as it comes in from our API request. So in fact, that's the next thing I'm going to do. Instead of logging this, I'm just going to save that inside the component state. So now when our API request is made, the data is then set. In fact, no, it's not yet. Now when our API request comes in, the data, if I say res.data, because that response object that comes back, we're only really interested in the data key, which holds all of our records. So I'm going to set that immediately in the response there. So there's one main kind of significant problem here. Because the data isn't returned instantly from the API request, we've got this then chain function in order to deal with it. When we move on to building the chart's going to try to redraw itself before the data comes back. So what we need to do is track the status of this API request in order to know when we can update the chart because the data has reloaded. So it's a little bit tricky, but it's often something that we're going to work with when we do API requests, is the ability to know when this promise has resolved, when this function has acted, and that will help us to update the chart or update any components that we need to at the right time and not before the data isn't ready. So I'm going to use a library called React Promise Tracker in order to do that. It's a really great and useful kind of lightweight library that just lets me track different promises that are made in API requests, and then it allows me to have a kind of loading variable which evaluates to true when the promise is in progress, and then when the promise is resolved, it's going to evaluate to false, so I can execute the code that I need to at that point. So I've stopped the server again. I'm in my terminal window, and I'm going to npm install React Promise Tracker. Brilliant. Okay, so that's going to give me access to two functions which I'll use to track this API request as it goes. So I want to import a couple of these into my chart.js. They're going to be called import use promise tracker from React Promise Tracker, and I also want track promise. So this use promise tracker is going to be used to set a variable that will evaluate to true or false, and I'm going to wrap my API request in this track promise function here, so that that promise is tracked. That will trigger that promise to give me that true or false value. So the first thing I want to do is underneath the lines where I've declared my use state hook, I'm going to go and declare my promise tracker. There's just a comment so I can find it later on, and I'm going to do object destructuring. So this is just going to evaluate to an immediate true or false value. Promise in progress equals use promise tracker, and I want to just set this as an area so that I know exactly what promise that I'm going to be tracking. So the area is going to be the API request, and maybe in bigger projects we might have different promises that we want to resolve, and we want to track the progress of those different promises. So that area variable just inside this object here is going to help us track the exact promise that we want to track. And the next thing I want to do just to track this promise is to wrap this axios.get function in a track promise. So I'm just going to load it differently like this, and that first parameter is going to be my API request, and the second parameter, just for clarity we can write that one first, is going to be the area. So this is going to be API request. And because this string is identical to this string, that means that both of these variables are going to look for the same promise to resolve here. Okay, so I'm going to copy and paste and put that Axios request in as my first kind of value in that function, and the second value is that area. So that's my promise is set up to track, and we now need to work on some of the other configuration points just to get that so our chart is drawn at the right point when that promise is resolved. It's not going to be too long before we start moving on to actually draw the chart as well, but all of this configuration stuff just helps us to have a really clean and highly performant application to work with. So we need to restructure the way that we're making our request next. We need probably another use effect hook, which remember we're using here to draw the chart, we'll also want a use effect hook that is able to make our API request. So the second use effect hook, we want to place this directly underneath the API parameters declaration, because we are using these two variables here. So if we placed it before, we're not going to have access to them. So I'm just going to write my second use effect hook is going to make a new date selection, is going to make a new request after user submits a new date selection. So that would make sense, because every time a user clicks on 90 days, 150 days, what we want to do is to update the component so that there's a new API request coming in with an appropriate data payload, and that can then get passed into our chart, and it will re-render with the correct amount of data. So we'll use the use effect hook just like this, an arrow function inside, and we want to set our dependency array to be the date selection. So that means that every time our date selection changes, this use effect hook will trigger, and we're just going to put the API get request, take that away, and put it inside the use effect hook. Add a bit of space so we know what's going on. And that's that set up. So we've now got the use effect hook here, which is going to trigger every time a new date selection is made. Remember, we're getting this date selection from the component props. And yeah, it's then going to send an API request off to our API URL. And when that promise is resolved, we're going to set the data inside this component state here. And once all of this code is complete, this track promise will resolve to false, so that we can draw the chart again. So that's the first thing that we need to do next. That's the next thing that we need to do, is to make sure that we're not trying to draw this, we're not triggering this drawing of the chart unless our promise is evaluating to false. And we also maybe need to put in a wee check just to make sure that the data is actually inside the array and we're not trying to plot an empty data array. So I can do that quite simply. I'm just going to add an if statement so that we're catching the promise whilst it's in progress, and we're not going to execute the code below. And we're going to put inside that if statement two conditions. The first condition would be that promise in progress should equal to false, and our second condition is going to be that the data array, our component state, which is holding the data, has a records attribute, so that we're checking for the records array is inside that data object. And this other query operator allows us to just check in line whether or not it has a length as well. So we're checking here whether or not the data has a records attribute, and that records attribute, which should be an array, and that should contain our timestamps and our values. We want to make sure that also has some values, has a length bigger than 0 before we execute this code below. And then I can open my brackets and just copy and paste the code to draw the chart and to select and clear the chart and then draw it again. I'm just going to make sure that all goes inside of this if statement here. And before we move on to kind of drawing the chart as well and just reviewing it a little bit, we want to make sure that we've got the right dependencies in here as well. So it makes sense to set this use effect hook to only update once there's a change in the two conditions that we've set as our if statement here. So if there's a change in the promise, and if there's a change in the the length of the records array that belongs to our data attribute here, then we should probably rerun that use effect hook so that we can access, we might be able to draw the chart at that point. So I'm going to set that in the dependency array, which will cause that use effect hook to update at the right times. So that would be data.records and check if it has a length. And the second part of my dependency array is going to be the promise in progress. Brilliant. So that's it. We've configured all of the data requesting, structuring, and storing methods that React and D3 need to kind of render and request data and then re-render again, which is a little bit of a configuration. It's not too easy, but we now have it all ready and up and running. 2 use effect hooks and an API request, and then a couple of conditions just to make sure that our API request is resolved before we start to draw that chart again. Okay, so we're now going to move on to working directly within this draw chart function, which we've declared down here, and we're going to start to build the D3, the chart with D3. So the first thing that I like to do when working with D3 charts is to get the viewport dimensions. So particularly the viewport width is going to correspond to, or give us dimensions as to how wide or how high, if we're using the viewport height, our screen is. And we can use this to dynamically set the margins of our chart and the dimensions of the chart so that it's going to respond well to different screen sizes as well. So I can use a couple of document attributes, the document object model, so I can set my viewport width inside the draw chart function. Most of the work that we're going to be doing now is inside this function. I'm just going to leave myself a comment actually, just to be clear. Get the viewport dimensions, the viewport width, and we're going to use document element dot client width, and then a little OR operator. If that equates to 0, then what we want is the window dot inner width or 0. And then we also need to wrap this in a math.max there. So that's going to give us the viewport width, which we can use to dynamically set. So now we're going to move on to working directly in this draw chart function, which we have declared down here. So most of the work we're going to do now is inside this draw chart function. We're going to move on to starting to draw the chart itself. So all of those different elements, the axis and the line ultimately as well. So one of the first things I like to do when I'm working with D3 charts is get the viewport dimensions. So these viewport dimensions are going to tell us the width or the height of the user's current screen or the browser window that they're using. So that's going to be re-render. If we do that inside the draw chart function, we're going to get it every single time we're drawing the chart. And that's going to make sure that if the size of the screen has changed, maybe people are working with a mobile screen or they minimize the size of their browser window, then our chart is always going to update so that it's going to be responsive to that viewport dimension. And the way that I do that is by selecting a new variable, which I'm going to declare const viewport width equals document element. So that's giving me access to the DOM, and I'm going to be the client width OR operator 0, and then I want window inner width as well, and that's also 0. And I need to make sure that I'm wrapping this in a math.max, so that's just going to round up, so it's always going to be an integer, and that's it. So I've got my viewport dimensions saved inside that variable every single time that my chart is redrawn. So that's not much use if I don't put them into the way that I'm setting my margins. D3 charts always need to have a wee bit of a margin so that the elements that are drawn inside of it aren't escaping outside of the bounds of that SVG container that we're returning here. So we want just a little bit of a margin in pixels to make sure that this is going to be positioned nicely and laid out nicely with not too much kind of a lack of space around the outside. So I'm going to declare a new variable here, chart margins, and I can call that chart margin equals an object, and we're going to have properties inside this object of left. We're going to have right, we're going to have top and bottom, and this is pretty standard practice if we're working with D3, is to set this chart margin variable in an object which has these 4 dimensions that we can use to dynamically set those margins throughout the chart. So something that's going to help our chart to be really responsive is to check how big the viewport width is in this variable, and then to dynamically set a different margin as we go on. So rather than just setting one margin which is going to be used for all screen sizes, no matter if it's 4,000 pixels big or 340 pixels wide, then the margin that we're going to use doesn't make much sense to be the same. So in fact what we're going to do here is just use some query operators, so this question mark, to check how big, if the viewport is over 900 pixels, then we're checking that with that query operator. If it's true, then give us a margin of 85. If that evaluates to false, do another check for the viewport width to see if it's bigger than 600 pixels. If that evaluates to true, then give us a margin of 60. And if that evaluates to false, then give us a margin of 50. So we've got these 3 possible margins that are going to appear. Either 85 pixels, 60 pixels or 50 pixels, and that's going to depend on the size of our viewport width. I'm going to do the same for the right margin. This time I don't need too much specificity, so I'm just going to check if the viewport is over 600. If it is, then give me a margin of 85. If it's not, then give me a margin of 20. For the top, I want to check if the viewport width is over 900, and then I'm going to get a margin of 75 if it is. If it's not, then I'm going to check if it's over 600, and then if it is, give me a margin of 60. If it's not, give me a margin of 35. And these are just optimized. I've had a look and I've built this project to find out which margins work the best, and these work the best for this chart, but you can always change the values for different kinds of charts that you work on as well, but the logic remains the same. What we're doing is we're checking if the viewport width is bigger than a certain number of pixels, and then we're setting the margin to be a specific number of pixels if it is and if it's not. So again, with the bottom margin, I'm checking if it's over 900, setting it as a margin of 65. And then likewise with the top, we're going to check if it's over 600. If it is, give it a margin of 60. And if it's not, give it a margin of 35. Okay, brilliant. That's our chart margins variable set up. So we can now move on to kind of dynamically set the height and the width of the chart. So we're going to store those in height and width variables depending on how big the chart SVG component is. So again, this is all about responsively setting up our chart to react to different screen sizes. Because we set this up to 100%, that means the height and the width of the SVG container is dynamic. So we'll need to make sure that we're getting the correct height and width of the SVG container every single time dynamically as we're drawing the chart. So I'm going to set up 2 variables here. I'm just going to leave myself a wee comment. Get height and width of SVG container, and const height equals document. So that's giving me access to the document object model. Query selector is quite a common command to select different attributes of the different elements, different HTML elements using IDs or classes, and I can use my chart.svg to select it here. And I'm going to use get bounding client rect, which is going to give me the dimensions of the SVG container in an object. So I then want to select the height attribute of that object and minus my chart margin dot bottom, which is going to set me a height which is already considering the margin that we've set, and it's considering the actual dimensions of the chart SVG container. So that's completely dynamic. I'm just going to copy this and set this one as the width, and then we want this to be the width that we're selecting here. We're still selecting the SVG container, and instead of minusing the bottom, instead of reducing the bottom, we're going to take away the chart margin dot right. So now we've got our height and width set up. Okay, great. So now we've got our height and width set up, and we want to move on to building our axis and grid lines. We've done a lot of configuration work, both with the styles and in terms of getting the data and integrating React and D3. Our actual browser application hasn't changed very much at all at the moment, but we're probably going to start to see that changing now as we set up our axis and grid lines. So I'm going to leave a weak comment and just say set axis and grid lines. Okay, so first thing we want to do is add a background rectangle to our chart. So this background rectangle, we're then going to put a color and just going to add a nice little bit of tint to the page so that the users know instantly where the boundaries of our chart are. So we want to declare the SVG, and now we're working with D3. So we're going to use D3 select, and we're going to use the chart SVG as the selector. So that's going to give us access to the SVG component here. And the way that this works in D3 is we start by selecting the SVG, the parent container, and then we start to chain functions which will manipulate that parent container. Again, this is why we would have had a problem if we weren't integrating React and D3 properly, because the SVG is manipulated by D3 from this point onwards. We're adding elements to it, we're styling, we're setting attributes of those elements. So if we weren't doing this at the right time, after React is re-rendered correctly in the use effect hooks, then we would be encountering some problems here. So the way that we've set this up is we've got the SVG container here, and we can now start to add a rectangle. So I can go svg.append, and if I choose rectangle, that's going to add a background rectangle to our chart. That's not going to do very much, so I'm going to set some more attributes, and this syntax in D3 is just chaining functions. So we've appended a rectangle, and now what we're going to do is we're going to assign that rectangle with an attribute of width, and that width should be the width minus chart margin dot left, and we want to assign it also with another attribute of height, and that height value is going to be height minus chart margin dot bottom, which is all dynamically setting our the boundaries of the chart using our dynamic height, width, and chart margin variables. Another one that I'm going to use is an attribute called transform, which is just going to transform. It's going to move my rectangle, my background rectangle, into the correct position a little bit, and then it's going to be translate, and we're going to close those brackets there. Just going to pass this string, so I'm just constructing a string here with chart margin dot left plus comma plus chart margin dot top plus, and then close my brackets as well. So that's a CSS attribute, which is just going to transform the background rectangle into a correct position. And then a final attribute for my rectangle we're going to add a fill so we can see it on the page, and I'm just going to copy in this this value here, which is just a nice grey that I've chosen to style that. So this is really typical syntax for kind of adding and editing elements using D3. We've selected the parent element, and then we're adding an element inside of it, a rectangle in this case, and then what we're doing is we're just adding attributes to that rectangle, which will cause it to style differently. So now if we save, restart the server, and I can go over to my development server, and I should be able to see in a wee second my grey rectangle appearing. Yeah, there it is. So nice and easy. I've got my SVG selected, and then my SVG D3 has added in a rectangle to that SVG. Brilliant. So let's add some X and Y scales to the chart. D3 has some really nice functions for calculating axis scales. So our bottom axis, our x-axis, is going to measure time. So it requires a scale time function so that we can correctly put different dates along that axis. And then our y-axis is going to measure integer values, so it's a linear scale that we're going to use there. So I'll explain a little bit about this as we go along, but the first thing that we need to do is work out what's the top value that we might be plotting in our data arrays. Because of that y-axis is going to be plotting the values of the objects that were counted at different times in the data. We don't know, in seven days that might be just 300 objects, whereas in 365 days, because that's a much larger time period, we might have had much more variation. So we don't know where is that y-axis going to end. It will all start at 0, but we need to find out what that max value is, and then save that so that we can dynamically update our y-axis to have the correct top value. I'm going to declare a new value here, so this is going to be let max value equals data if it has an attribute of records. This is just a sanity check. It should always have an attribute of records, which will have a length, because we're checking that inside our use effect hook here, but I'm just doing a quick sanity check just to make sure that it does. Dot length, if it does, give me the math.max, so I'm going to get the highest value in spread operator data dot records dot map, and then d arrow function d dot value. So that's going to give me the highest value that's in my data array. But if there's no if there is, I'm using this query operator here to check if the data has an attribute of records and that has a length. If it does, then I'm going to get the highest record in that data array here. And if it doesn't, I'm just going to use the default value of 1000, so that we're going to get an axis no matter what. We've got all of the values now that we need to kind of declare our X and our Y scales. So let's move on to doing that. Firstly, I'm going to do the X-axis, which remember is a time axis. So X-axis will be declared here, and const X-axis equals d3.scale time. That scale time is a really handy function that we're going to use to plot the date variables on that x-axis here. And similarly, in the way that D3 has worked before, we're going to actually just chain some functions on here. So D3 axis have two really important features, if you like. That first one of those features is the domain. So that domain is telling us the highest and lowest values that are used in the scale. So the domain this time is going to be an array. In fact, yeah. So the domain is going to be an array. And the first value in that array is going to be a new date. And we're going to use the d3.timeFormat function again. And this time we want a different time format. We want hashtag B space hashtag D space hashtag Y, and that's going to give us the correct format that we'll need for this axis here. And then the second argument is going to be our date selection. So that means that the first value in the domain, the highest and lowest values, the lowest value is going to be the user's date selection, which we've just put into a good format, and the highest value, because our chart is always going to go up to today's date, is going to be just a new date object, like that. And just remember that we've just wrapped this in fact, I've not done that correctly. That bracket goes there. We've just wrapped that d3.time format call in a new date object, so it's always going to evaluate to a new date object. And then the range is the other feature. So this range is telling us the actual dimensions on the page which we should draw our axis. So what's the furthest dimension? What's the furthest left dimension, and what's the furthest right dimension? So that sounds a little bit complicated, but really all we're picking out is a couple of pixels, which is telling us where our x-axis needs, which points on the page, on the screen, we need to draw our axis. So the first value is going to be chart margin dot left, and the second value is going to be the width of the page. So that's going to nicely put our axis right in the middle of where our rectangle is just now, and we're going to be able to plot that axis correctly in the right place. And finally, I'm just going to wrap this in a nice function, which is a really nice way of just making sure that the values in our axis, no matter how they're rendered, if they're updating, if it's over 7 days or 365 days, that nice wrapper just at the end is going to make sure they match up to either point at the end of the axis. It's a really nice thing to do, otherwise our axis can look a little bit messy. Okay, so that's brilliant, and now we need to set up our y-axis. So const y-axis equals d3.scaleLinear. And we're going to set up exactly the same way that we have done for our x-axis, a domain and a range. This time the domain is going to be to do with the top and bottom values that we want to plot on the y-axis. So the top axis is always going to start from 0. So we need to start that from 0, and it's always going to go up to the max value, which we've set dynamically to be the highest value in the array, or 1,000. So the max value will be set there, and the range this time doesn't go from left to right, it goes from top to bottom. So we've got the height as the first value in that array, and the chart margin dot bottom to be the range there. So that's going to go vertically rather than horizontally compared with our x-axis. And finally, just to make things look a little bit nice, we're going to wrap that all in a nice function as well, which means that we'll always get kind of round numbers at the top of our value, top of our axis as well. So that's great. We've set up the functions, and now we can start to put the axes on the page. So the next thing we need to do is to draw the x-axis, and we can do that by selecting the SVG, which we already have access to, and we're going to append a group element, and inside that group element we're going to call our x-axis function to draw our x-axis on the page. So we want to do svg.append, and we're going to append a group into the SVG, so a G element, and then we're going to give that G an attribute of transform, and we're going to transform it so it goes into the correct position on the page. So we're going to translate it so that it goes to the bottom of the page. So it should go to the bottom of our SVG container, which we've saved with our height variable here. And I'm just going to close those brackets just like this. So that's transforming. It's going to put our x-axis, when it's drawn, right at the bottom of the page where it should be. And we're also going to give another attribute. In fact, we're going to call our D3 x-axis function now. So this is d3.axis bottom, and it's going to be the x-axis function that we've used. And inside here, I also need to call the ticks, and we want to make sure that we have some, the ticks are the little labels that appear to show, to demark the different dates that are on our axis. So depending on how big our viewport screen is, we're going to want more ticks. On mobile screens, we're going to want less ticks. So what I'm going to do here is, rather than just setting a generic value that we want 10 ticks, I'm going to say that the viewport width, if that's bigger than 900, if that's bigger than 900, give me 8. If it's not bigger than 900, give me 4. And then similarly, we're also going to use the tick padding, which is just going to give us a bit of padding around the ticks. They're not really close to the axis itself. So the tick padding, we're going to do another check to see how big the viewport is here. If the viewport's bigger than 600, we want a padding of 15. If it's not, we want a padding of 8. That's brilliant, and that's our x-axis setup. So we also want to set up the y-axis here as well. So draw y-axis, and that's going to follow a very similar process where we're just choosing the SVG and appending a G. And then similarly, I'm just going to write another attribute, which is going to transform and put our y-axis to the far left of the screen so that it's in the correct place as well. Translate, and this is going to be the first value in that translate is going to be the chart margin dot left. And then the second value is going to be 0, so I can use and then close the brackets. And that's the axis, the y-axis set to appear in the right place. And then I'm going to call my y-axis function just here. So d3.axis left. Excuse me. I'll just move this up so we've got a bit more room. d3.axis left. And we're going to call the y-axis here, and then the same way that we did for the x-axis function, we're going to check how big the viewport width is. If the viewport width is bigger than 900, then give us 8 ticks. This is going to be the labels that are appearing alongside the values as they increase, the counts of objects, so the y-axis, the left axis. Viewport width is bigger than 900. Give me 8, if not, then give me 4. And similarly, with my tick padding, we're going to have the viewport width. Is it bigger than 600? And if it is bigger than 600, give me 15 padding. And if it's not, 15 pixels padding. And if it's not, give me 6. So that's our tick padding and our ticks just set up so that they're going to be responsive to different screen sizes. And I'm just noticing that I have an extra transform translate. So yep, in fact that needs to go, and we can probably start the server and just make sure that's running. And yep, there we go. We've got our axis on the screen. Looking good, and it's going up to 12,000, which shows that our data has been loaded properly, and we've got November all the way to December. That's 360 days worth of data. If I change this, then we're going to get new values appearing on all of the axis, which is great. It's showing that our chart is up and running. So the next thing that we want to do is just add some grid lines into our chart to make it more usable. So we're going to do that in a very similar way to adding the axis. We're going to use the group attribute. So we're going to append some groups to our SVG, and we're going to transform and translate them again so that they're appearing in the right pages. And then we're going to call our axis functions again, which is then going to periodically draw our axis at all of the tick points that are on, our grid lines, sorry, at all of the tick points that are on the chart. So adding grid lines here, and I can just svg.append another group element, and the attribute of this group is going to be, we're going to first do the the X scale grid lines. So we're going to start working here with transform and translate, and this is just going to position our axis grid lines on the correct places across the chart. So 0 we're going to start from, and then plus height, plus, and then we're going to close our brackets. Excuse me, that's just that there. So that's going to position our X scale grid lines on the right place across the chart, and then we're going to set our axis call. So we're calling D3 axis bottom here. So these are going to be vertical grid lines, axis bottom, and that's going to be with the X-axis. And the X-axis, we're going to wrap this again. I'm just going to make it a bit more readable, and we can go with more chaining, and we've seen these before. We're just going to set the ticks. This time viewport height is bigger than 900. We want 8 axis grid lines, and we're just using, what we're doing here is we're mirroring the ones that are already here, so that we're going to have the same ticks at the bottom of the axis as the same grid lines that are appearing across the chart. So if it's not 8, it should be 4. And then secondly, we have the tick size here, and the tick size is minus, and then height minus chart margin dot bottom minus 10, and the tick format is just going to be an empty string because they're actually grid lines instead, and that's going to add our grid lines in nicely for the x-axis. And now we want to add our y-axis grid lines, so we're going to repeat the process, svg append another g element, and similarly we're going to add an attribute of transform, and we're going to translate this one so that it's starting from the left hand side of the chart and then moving across. So the translate would be translate, in fact that should be in a string, translate plus, and then open brackets chart margin dot left minus 10 plus, and then a string that tells us to close with 0. And then again we're going to call this using the x-axis function, so d3.axis left, and then we're going to add in our y-axis function here. And again, to make things a little bit more easy to read, I'm just going to open that up and add ticks in here. So again, we're going to mirror the y-axis configuration to check if the viewport is over 900. Then give us 8 ticks. If it's not, give us 4 ticks. And the tick size is going to be is going to tell our ticks to stretch all the way across the chart. So we want to do minus, and then width minus chart margin dot left this time, and then minus 10. And finally our tick format is going to be the same again because these are just grid lines. So that's brilliant. Let's go and have a look and see how it looks in our browser. And that's it. We've got our chart axis all set up nicely, and we've got our grid lines appearing across the page as well. Okay, so what we're going to do now is moving on to plot some data in the chart, which we do already have access to in the component state. We've got it saved all the way up here. Data, our chart file is getting kind of big now. So these comments are becoming more and more important. We're still working within the draw chart function. We haven't moved outside of it for a while now. And I've got my axis and I've got my grid lines. So now I want to add a new section, drawing data, into my draw chart function. So to draw the chart, what we're going to do is we're going to add another element to the SVG to add the line. And we're going to do that by selecting the SVG, excuse me, appending this time not a group element, but a path. So this path will plot the data that's in our data array that was requested from the API. So we're appending a path, and then we need to tell it the datum to use, which is the data, and if it has an attribute of records, so that records array is going to be mapped by this line and then plotted on the chart. I'm also going to give it a class, so we can later use that to style. In fact, it's attribute, we're going to give an attribute, and that attribute is going to be the class, and then it's going to have a class of line path, and we can use that to style that line path in CSS later on. It's going to have another attribute of fill, and it's going to have none as the fill. It's going to have a stroke, and we do want it to have a stroke color, so the attribute stroke would be hex code, and that hex code is hashtag FF729F. Hashtag FF729F, and as we can see here, that's just going to give us a nice red contrast to the blue color theme that we're using in Material UI. And then another attribute is going to tell us the stroke width. And the stroke width, we want to do another check here. We don't want really big, we don't want really thick kind of lines on smaller screen sizes again. So we're going to check whether our viewport width is bigger than 900. If it is, then we want a stroke width of 2 pixels. And if it's not, we want to check if the viewport width is bigger than 600. If it is, we want a stroke width of 1.5 pixels. But if it's not, then we want a stroke width of 1. So that's giving us a nice dynamic way to set the stroke width, so that on the smaller screen sizes we're not getting a really thick chart, but on bigger screen sizes it's going to be much clearer. And then finally, the attribute D is going to associate the data records array with the data in the chart. So what we do here is call the D3 line function, and then we're just going to chain on some other functions here, X and Y. So X is going to associate the data function data, and it's going to return the X scale, X axis, and then new date, and then inside that date we're putting D dot time stamp. And similarly for the Y, we want to plot that, so we're associating this line with the data that with the values that are associated with each timestamp. So remember, we're mapping through the array and returning the timestamp. We're going to make that into a new date, and we're going to plot that on the x-axis. So what we're actually going to do is animate our chart. So at the moment we're just going to return D and then return height. So what we could do here is also plot the the value that's associated with each timestamp, and that would cause our chart to render properly. But in actuality, what we want is for a bit of animation every time the user selects a new date using the toggle button group. So we want the chart to start from the bottom and then to rise up into its correct value. So if we return the height here, that's going to tell the line to just start from the bottom. It will draw all of the X values correctly. It won't draw the Y values. And then we'll use a little bit of animation in a second just to draw those Y values correctly, and that just helps with a bit of usability so that the user knows that their selection has made an effect on the chart as much as anything else. So if I save that, and we can just have a quick look, and we can see that we've actually got a line, and it's plotted all the way across the bottom axis, but it's not going up just because we're returning this height as the value. We want it to be on the y-axis at the moment. So next thing to do would be to position the chart correctly. We're still working within the inside the draw data, the draw chart function, and I'm going to animate the chart to position it correctly, and don't need to add anything in here because I've got all of my elements already in. This D3 line function is accessing the path. What I need to do here is kind of repeat that process in an animation. So what we're going to return the timestamp again for the d3.line.x value, but this time we're actually going to return the correct y value, and we should start to see that the chart is going to update nicely here. So d3.selectAll, and I'm just going to use the line path because we remember we're setting a class here, which now means that our this line is available through the .line path class selector, and I'm going to set this to have a transition, which is the way that D3 allows us to use animation, and that transition is going to have a duration of 1,000, so 1,000 milliseconds, 1 second, I think, and then it's going to have another attribute where we're just going to call this D3 line function again. In fact, I'm just going to copy and paste this because that's the easiest thing. And instead of, this is going to remain the same, so we're still going to return the x-axis, but this time we're going to return the y-axis, and we're going to have d.value. So that's going to hopefully plot all of our values on the correct scale on the y-axis as well. So let's have a look in the browser and see what that looks like. And yep, that's it. We can see that we're now actually plotting our chart, which is really nice to see. After all of that configuration work, we're actually getting a chart with the correct values shown in it now. Brilliant. So probably want to move on now to adding some final styles to our chart and our date filter. First of all, I just wanted to check that this is all working and it's going to update nicely. So we're starting to see the real fruits of our labor in the sense of setting up all that configuration work with the use effect hooks. This is rendering really, really nicely. Every time I'm selecting a new date selection, we're getting a new API request, which is then resolving from our CCTV object detection API, putting that data into the chart, and then we're not redrawing that chart immediately. We're waiting until that promise is resolved, and then we're drawing the chart again. And all of that's happening as soon as I click another button on this toggle button group at the top. So the last thing that we want to do really is to add some final styles. What we want to do, we want to hide these axis labels. The axis labels. We want to hide these axis lines to make that a little bit more readable. We want to change the color of the grid lines because they're quite obvious right now, and then these labels are actually really small, so we want to make them uppercase so they just become a little bit more readable. So I'm going to start by creating a new file inside the SRC directory, and I'm going to call that file chart.module.css. chart.module.css. I'm going to add that, and immediately I'm going to import that into my chart .js file. So import styles. It doesn't really matter what we call that, from chart.module.css. Brilliant. So now I've got access to all of the styles that I choose to create in here directly inside this chart.js function. So we're going to need to add a series of class names to the elements as we're adding them with D3 inside our draw chart function. and we're just going to add some classes that will give us ability to style the elements as we add them. We can style them inside that chart.module.css file. But the first thing I want to do is add some class names. So as I'm adding the x-axis here, I'm just going to, before I even translate anything, I'm going to add an attribute, and that's going to be a class attribute, and that's going to be called styles.chartAxis. And I can copy and paste that because the axis styles will be the same for my x-axis and my y-axis. We haven't declared this, so don't worry if it looks a little bit weird. I'm just adding the class names in before we then go and create them in the chart.module.css file. So now we've got the class attribute added to both of our axes, and that's called chartAxis. We also want to add the chart grid, a class to the chart grid lines. So I'm going to do the same again here. For my grid lines for my bottom axis, I'm going to call this chart grid, and I can copy and paste that and just pop it in here as well. So all of my grid lines are going to have the same styles. And now we can finally move on to adding these styles ourselves. So we go over to the chart module.css, and the first thing I want to do is select the chart axis and the text that falls inside the chart axis. And then I can open the brackets and add my CSS rules that are going to style the labels in the text in the axis. So this would be a text transform, is going to make it all uppercase, and I want it to have a font weight of 200, that's going to be quite light, and a font size of 14 pixels, and a margin at the top of 10 pixels. Okay, the next style that I want to add in here would be to do with my chart grid and the lines that are appearing in the chart grid. So these are all the individual elements that are added as we're adding our grid lines, and we want these to have a slightly lighter stroke color, so we can go with light gray, and we can have a stroke opacity of 0.7, which is going to make them even more faint. We don't need our grid lines to be too dramatic on the page. We just want them to guide the user in seeing kind of what values are where on the chart. And there's a nice shape rendering CSS rule with crisp edges, just going to make it all a little bit more crisp as well. Just before we have a look at this, I'm going to add another one for chart grid, and that's going to be the paths that are inside the chart grid, and we want to hide these. So the stroke width will be 0. Okay, great. Things are starting to take shape. Let's have a quick look. Okay, our chart's already looking a lot better. That's looking a lot cleaner. And we probably want to just hide these lines a little bit. As we can see, you know, there's no real reason to have those lines on the chart. It's matter of preference really, but we've already got lines there that we can use, so I'm just going to remove them and make the ticks blend in a little bit more as well. So the chart axis lines within the chart axis, we're going to set them to have a stroke. We don't want to remove them, but let's set them to have a stroke to blend in, and that would be a hex code of E5 E5 E5. And the chart axis path lines should have a stroke opacity of 0, so we are going to hide those. Okay, great. Now have a look at what we've got, and all of a sudden our chart looks a lot nicer, and we can switch that around, and that's presenting our data pretty clearly now. We can start to see exactly what's appearing and when, and our grid lines are nicely kind of blended into the background rather than being very visible on the chart. So the last thing we want to do is kind of make our CSS rules are media queries that are going to make the chart much more responsive to mobile screens. If we have a look just now, and I can emulate, if I'm using Chrome, I can have a look at what it's going to look like on an iPhone Pro 12. I can refresh the page. We can see that it looks okay, but there's a few things going on here which could look a lot better. And this is something which we have helped out by making all of these queries that we've put, checking the viewport width, checking the viewport width in order to see how big our dimensions are, and then setting the margins and the height and the width dynamically. But there's also a few things that we can do towards the end to make this a wee bit better as well. So I've got iPhone Pro 12 selected in my browser, and what I'm going to do is I'm just going to optimize a few elements here. So I'm going to go back to my app.js file, and I'm going to choose this chart container, which is this box, and I'm just going to give this an ID so that I can style it inside CSS. And that ID is going to be chart container, which means that I can now select this box and then kind of add some media queries to make that a little bit more responsive using CSS. So open up that. I'm going to open up the app.css file, and at the bottom of the page, I'm going to add a media query, which is media only screen and max width. So this is going to be only applied to screens where the width is under 600 pixels, and everything inside here will be added as a CSS rule when this media query is hit. So I'm going to give it a padding to my entire application. So as we can see here, everything is going right up to the edge of the screen. We don't want that. That doesn't make for good usability. So if I just add a padding of 2.5%, we should start to see a wee bit nicer display here. And let's check that out. And yeah, we've added a bit of padding. It's definitely moved our date filter away from the side. We'll sort this out with the axis labels in a second, but generally that looks a wee bit better. And the other thing that I want to do is select my chart container and make sure that actually only has a height of 55 viewport height, because there's no point in that going all the way up to the top of the screen. I'm going to refresh the page and the chart draws again. And that's looking a lot better for mobile screens. So we see with how a couple of media queries, we've already got a responsive chart, but with these media queries, we're just controlling some general rules, which makes it a lot easier to read on mobile screens. I want to go back to my chart module.css. I'm going to fix this problem with the axis labels, just so that on smaller screens, they're not falling outside the realms of the SVG container. And I want to add a media query because this only affects renderings when the screen is smaller than 600 pixels. So I'm going to add media only screen and max width 600 pixels. And this time I'm going to select the chart axis and the text within the chart axis. So that's again giving me access to these labels. And I'm going to change the font size so that it goes down to 10 pixels. We don't need huge font sizes on smaller screens, so that should have solved that problem. That looks a lot better. Okay, brilliant. And we can just play around with this here, and as you can see, it is starting to look a lot better. There's plenty more that we could do to optimize this for mobile screens, but just as a general rule, it's a really good thing that we've got our dynamic screen height and width plugged in, so we can use those variables to control the margins and dimensions of the chart itself. And then we're also adding in some media queries at the end here as well. So thanks very much for following this guide. I hope it was useful. You could also try to add in a loading skeleton or a loading spinner to indicate to the user that an API request is in progress. Or you could try to have a go at visualizing other variables that we're getting back from the API, such as the object types or the camera locations. There's plenty more to play with here, but I hope that was helpful.